Alright, solving simultaneous equations using matrices, part 2, the tricks. There are quite a few tricks, and it's always important to think about it in terms of tricks because they might change the numbers, but there's a limited number of tricks they can use in exams. So these are the tricks we got here: that the row order doesn't matter, scaled answers, missing values, rearrange the equations, solution not problem, determinant confusion, and just some bonus ones. Alright, so row order doesn't matter. So on the previous video, I did do this one, and you would have said, well, hang on a minute, 2, 3, 5, but I can do them on the same, as long as I'm on the same row, the 2, 3, and the 5, and then the if we did then the one that was here, 1, -4, -4 there, and -14. They're on the same row, so the row orders can be flipped up and down, and you can see that I've done it on the calculator over here. That the first answer got us -2 and 3, but then the other one, if I flip the rows around, it got us -2 and 3. So the row order doesn't matter. There's nothing special about this. Which one's equation 1, which one's equation 2. So the row order doesn't matter. They might try and trick you with a multiple choice that, you might go, oh, this isn't the solution because it doesn't have the 2 and the 3 and the 5 at the top. And they might try and trick you though. How would they try and trick you? They might do something like this. They might go 2, 3, 1, -4, and then x, y equals -14, 5. It could be like that. Or they might do something like 1, -4, 2, 3, and then they'll try and trick you by putting the 5 up here and then -14 down there. So you can see that where they can do some tricks on you, they have to be in the same row. So this one is wrong because the 2 and the 3 are with the -14, which is wrong, and the 1 and the -4 are with the 5, which is wrong. So when we're having fun on exams, as we're always doing, and we've got our A and our X and our C set up nicely, and we know the answer for this is X equals A to the -1C, and we just got to stick that in the calculator, and it's going to be great. And then we can find the answer on the multiple choice question. So we do all that on the calculator, and it spits out this lovely answer, 8 and 4. And then we look at our multiple choice answers, and that's not there, because what they might do is scale the answers, because they know that you're doing this on the calculator. So they won't give you 8 and 4. They might do things like go, oh, here's 4 and 8. And you're like, oh, I must choose that one because it's got the numbers, but just flipped order. That's wrong. But they might do something like this. They might go, oh, here's 4, 2, 1. And that's the correct answer because they've taken a factor out. So if you do 4 times 2, you get 8. And you do 4 times 1, you get 4. So just be aware. They know you're using the calculator, and they'll try and trick you by giving you an answer where they've taken a factor out. Here's another even trickier example. We got A, X, C, and we know the answer for X equals A to the -1C. So we go straight to our calculator. So you've hit your calculator and it spat out this answer. And you're like, well, I might press that button and get me this. So that button switches between the two. So if you want to switch between those two, one's decimals, one is fractions, and you're suddenly panicking because you can't find that answer in the multiple choice. What they might have done is actually taken out a factor. So if you took out 1/4, well, 1/4, that's 2 and 1. It might be something like that they might give you as an option on the exam. And it doesn't look like that, does it? But just remember, if you multiply 1/4 by 2, you get 1/2, and 1/4 by 1, you get 1/4. So another example of where they might factor things out. They'd love to take a factor out the front just to annoy the people on the calculators. So we're just going to set this up first and see what's going on. We can see that there's 804 on all of them. So that's not what we're looking at as the difference. What we've got to look at is these equations here. I'm going to set up a matrix for that and see how we go. Now, the trick here to do this is to label them X, Y, Z. And we're looking at the coefficients. That's the numbers in front of them. So we're looking at this first equation here. And if you look at that, there's nothing, there's no X. So 0 for the X, 1 for the Y, and then -1 for the Z. And we can eliminate C because it's not even the right order in the matrix there. And it's looking pretty good to eliminate D and E. But let's not rush to that because they might have done that trick with changing orders. So let's just do all of them first before we get too excited about maths. Now, let's have a look at the next one. We've got 5 in front of the X, minus 1 in front of the Y, and there's no Z. And the next one's a classic one because you know people stuff this up. You got the X and the Z, and people go, oh, look, 1, 1, 0, done. Ooh, no, pay attention. 1 for the X, no Y, 1 for the Z. And I can see that the answer B there seems to be making a whole lot of sense. All my numbers match up, so they haven't been annoying with the row order. I don't think fancy like that. And that leaves A out. And it's just really, really important when you're doing these things, label the top X, Y, Z, and make sure they all line up. So the first equation was missing an X, the second equation was missing a Z, and the third equation was missing a Y. And often people misalign those things because they haven't labeled the top. This is a classic trick of working backwards. So we know this row by this column gives us this. So we should have an equation which goes 1 times X plus negative 2 times Y plus 0 times Z equals 4. So that's X minus 2Y equals 4. Can't see that just yet. Let's just do all the equations and see what happens. So I'm going to do this slowly. So we've got this by this gives me this, because remember, second row gives me the second answer. So that's going to be, the second equation is going to be X. Now it's not the 0 times the Y, and then 3 times the Z, so it's plus 3 Z equals 11. That's looking pretty good for D, isn't it? Actually already, but let's just for practice sake, this by this gives me the third one. So we've got no X, 2Y minus Z equals negative 5. And you can see they were trying to trick us with C for that one, but it's that bit's wrong there. X plus Y plus 3Z, that's if you didn't pay attention to that 0, so that's where that one was going wrong. X minus 2Y plus Z, again, that's people 0, there shouldn't be a Z there. And the last one, 3Y minus Z equals negative 5. It doesn't even make sense. So the answer for that one was D. All right, this is a trick called solution not problem. So we've got answer A here and answer B here. Which one is correct? Now you sit there and you go, oh, look, I'll just set up my matrices like I did last time, like this, and I go my X and my Y, I got my Z, and I'm very happy. I've got 1, 1, 0, and I've got 0, 0, 2, 1, and I got 2 minus 1 minus 1. This is all looking good. It must be, wait a minute, it's not, because it's not A, because this is, remember, this is A, but we want, this is X equals A neg 1 C. So if you actually put into your calculator the A neg 1, then you'll actually get the correct answer, which is this is the matrix we want. And so the correct answer is actually B. So it's a nice little trick that they've given you in the format X equals A neg 1 C, and you've worked out A, and you think it's going to be this first answer A, but it's not. Okay, the key thing here says unique solution. So a matrix has a unique solution when the determinant of A does not equal 0. Now, you could do this on the calculator, but it's going to take you too long. This is only question 3. You need to be quicker. AD minus BC is what we're looking at here. That's AD, so that's 1, minus BC, which is 1, that equals 0. That's AD, 24, minus BC, so that's negative times a negative is a positive, so that's positive 24, but we're minusing positive 24, so that's 24 minus 24 equals 0. This is 16. 4 times minus 4 is negative 4, but we're minusing a negative, so that's plus 16. That equals 32. That looks like C is the correct answer. 7 times 0 equals 0. 5 times 0 equals 0, so that's 0, that's obvious. 4 times negative 3, that's negative 12. And then that's negative 12, because 6 times negative 2, but it's plus 12, so that equals 0, because we're subtracting a negative. And so that's what it is. If you spent time on your calculator on this, you'll spend too long and you won't have time for other things. They know the smart kids will be doing this the way I've shown it, and that's why you need to learn how to do that. And learn your times tables and how to multiply negatives and subtract negatives quickly in your head. You can check those on your calculator, but if you typed in all these matrices and then worked out the determinant of them all, you spent far too long on this question. All right, so we want no unique solution. Translation, det of A equals 0. So because we want no solution, we want this det to equal 0. So we've got to work out a value for m so that the determinant equals 0. So we know that we want AD minus BC equals 0. So looking over here, that's 12 times 3. So AD is 36 minus, that's 9 m equals 0. So you can do some solving on your calculator and all those kind of things, but basically what value of m will make that work? Well, 4. So because 36 minus 9 times 4 does equal 0. Okay, how many of these systems of simultaneous linear equations do not have a unique solution? So do not have a unique solution means that the det of A equals 0. So how many have a determinant of A equals 0? So if we look at this, we need to be doing this minus this. So that's 24 minus 24. That equals 0. And then we do this, which is 15. Well, that's 14. So even if you know your maths, I mean, you know, you can see that, like, even though we're going to be minus of 14, that equals 1, you can see the numbers don't even work out. So you don't have to worry about your pluses and your minuses. Let's try this one. So that's minus 12. That's plus 12, but minus another 12. So that equals negative 24. Tricky one with the pluses and negatives. That's 1, and that's a half times a half, which is a quarter. So that's 1 minus a quarter, which equals 3/4. I'm old school that way. So it looks like the only one that doesn't have a solution is the first set, which means the answer is B, 1. Again, there can be some more confusion with determinants. If we look at this one, you might be thinking, well, look, you know, the determinant's out the front here. So you might think, oh, well, the determinant equals 1, because that would be 1 over 1 times 0.5 minus 1, 3. That would mean, remembering the determinant is only the bottom bit, that it is actually 1. But guess what? It's not the answer. So if we look at this, we can actually take a half out the front. And I like to do it as a half, not a decimal. So that's 1 minus 2, because a half times minus 2 is minus 1, minus 2, 6, like that. And now we can see the determinant, just the bit at the bottom, not the whole fraction. That's another trick they might play on you. So the determinant of that was actually 2. Then don't get tricked, don't call it a half. And if you just want to check my maths there, I've just shown you that actually the inverse of this matrix does give me that on the calculator, but if I do the determinant of it, it does actually equal 2. Now this is from the 2018 exam 1, and basically you've got a matrix here and another matrix here. So this is A and this is C, right? So you want, what does X equal? You want A neg 1 C. So you need to just basically put that into your calculator to get the answers, because basically, although it's very much hidden in this whole sort of thing, like you've got this CRSW thing, that is matrix x, and they're basically just asking you what is x. So there you go. I've put this matrix here into here. Sorry, there isn't much room on these things, and that matrix into there, and I haven't forgotten to do my hat neg1. Now, if I move everything up, save some paper here. Write shorter exams. 8619. There's 8619. So the answer was B. Now I've done the second part, part II of this question before, but now I'll do the first part. So you can see we have got the classic situation of A, X, C. So we want to know what A neg 1 C equals, and that will get us the answer that we're looking for. So we put all that in the calculator. So this is put in there. That's your A, and then we put our neg 1, and then we put our C. All right, so that's our A neg 1 C, and it spits out this answer. But the question's asking the cost of one sandwich. So we know this is A, B, C. So the answer for C is 3.8, and you're wrong because it said cost. So put a dollar sign and give me 2 decimal places, and then you'll get your 1 mark. And I did do this on another video, but the next part was just asking about how to get a matrix for rolls and sandwiches. This is basically a summing matrix, but it doesn't want the pies, which is A, because it's got A as the pies up there. So the answer for this next one is you need L is 1 by 3. It's apparently quite amazing how many people didn't know rows by columns. We don't want the pies, we want the rolls, and we want the sandwiches. And so the answer for that one was 0, 1, 1. More on that in my summing video. All right, so it looks like we've got some matrix multiplication going on here. And it says that because we've got that lovely word for multiplying, product. We want the amount in dollars raised by each year group by selling trees. So we want each year group, there are 2 year groups, so we want an answer that's 2 by 1 or 1 by 2 in its final answer. So let's do that quick thing. This is a 2 by 3, and this is a 3 by 1. So yes, it works, and our answer is going to be 2 by 1. So that one's looking so good so far. This is 2 by 4 and 4 by 1. So yes, it works, and we get a 2 by 1. But what's that? And why do we have the 7 and 8 in there? No, B, all wrong. This is 1 by 3, and then it's 3 by 2. So yes, it does work, and we do get 2 by 1 or a 1 by 2 in the answer. Yeah, what's this random 0 stuff going on here? 1 by 3 and 3 by 3. Well, that works, but then we've got this 3. No, not working. And then there's this tricky dicky down the bottom here, which might be sort of freaking people out, because you have to add first. Look very carefully here, and there's an add. So if you add those two together, you would actually have still, because they're the same order, you can still add them together. That would actually be 3 by 1, and that's 1 by 3. But you can multiply them, but your answer will be a 3 by 3. So we already know that one's wrong. Don't do that thing where you think the most technical looking one is the right answer. So we already know it's between A and C. So we've got that matrix here, and we can see it in both of them, but one of them has got it transposed. So that's not really helping us, is it? But it says a matrix product that can be used. We have to have another matrix here, which has got this 32, 26, 18. And see, this 32, 26, 18. They haven't given you that other matrix, but that makes it look like C is the correct answer, because that needs to be a separate matrix from the other one. So A is not right, even before you've even done any multiplication. Okay, this is from the 2015 exam, and who wrote this question? It's a horrible question. Feel happy to stop the video right now, go away, take a break, and go and look at some of my other videos, because this is a horrendous question. What they're saying here is that WP equals Q. All right, now, if we do some lovely algebra, if we multiply both sides by Q inverse, because we want to find Q inverse, that's what it's asking us to do. So we just multiply both sides by Q inverse. We can see then that WPQ inverse, now that equals the identity matrix. Any number times its inverse is itself. And then we can divide both sides by W. So we end up with PQ neg 1 equals 1 on W times I. Then we can insert another like times P to neg 1 times P to neg 1 in there, because then this just ends up being Q to the neg 1 because this is just I, and I times anything equals itself, and this disappears, so it equals 1 on WP to the neg 1. Hey, the answer was A. 43% of people got that right. I'm sure there must have been a lot of lucky guessing in there. I'm a teacher and I would have hated that question. Who wrote this? Hang your head in shame. You're still here? Go get a cup of coffee.